So going back to the fraction work that we've been doing before, our most recent fraction work we had done was just converting mixed numbers into improper fractions or improper fractions into mixed numbers. Well, since we know how to do that and we got that technique down, now we can do the operations on the mixed numbers. Because the first step when you're going to multiply or divide mixed numbers is to turn each of them into improper fractions. And so that's what we're going to do for each of these. All right, so our first one here, 1 3/5. Remember, I multiply the 1 by the 5, which gives me 5. Add it to the top, so that's 8/5. Okay, so we got 8/5 times, repeat for the second one, 5 times 2 gives me 10, plus the 1 on the top means that is 11/2. Now that I've written them as improper fractions, I can go ahead and multiply them. I could not have done it otherwise. All right, so now we go ahead and multiply. 8 times 11 on the top. Yeah, it's without calculators, but we can do that. What is 8 times 11? 88. Because anytime you multiply a single digit number by 11, it just gives you 2 of those digits. And then 5 times 2 on the bottom, of course, is 10. Now, the tricky part with this is that I then have to take this and turn it back into a mixed number. Because if I start with mixed numbers, I want to end with a mixed number. Well, I made this one fairly straightforward. I hope to do so. How many times does 10 go into 8? It goes in 8 whole times. With how many left over? 8 left over. So it's 8 and 8/10. Although this is not what I want to see as my final answer, is it? Because you notice it reduces. So it's going to be 8 4/5. Remember that the whole number part, it doesn't change. So I just divide the 8 and the 10 there, both by 2. That's the final answer we're looking for, is 8 4/5. You're done. All right, now for the division problem. Step 1, exactly the same. Step 1 is to turn each of those into a mixed number. When we turn each of those into mixed numbers, or into improper, we do the 3 times 3, which is 9, plus the 1 on the top. That gives me 10/3 for the first, divided by then 1 times 6 on the second one, which is 6, plus the 1 on the top gives me 7. So that is 7/6. Now this is division. I got another step I can do before I actually start combining that into a single fraction. Remember how we divide by a fraction. We flip the second fraction, and always the second fraction. Doesn't matter which one's bigger or smaller or anything like that. It's always the second fraction that gets flipped. And at the same step, I change that division symbol to a multiplication symbol. That's all one step. It has to be all one step. Now, it's just a multiplication problem like that last one was. So, multiply straight across the top. 10 times 6 is 60. Multiply straight across the bottom. 3 times 7, that's 21. And now, we need to get that back into a mixed number. Okay, how many times does 21 go into 60?
Twice.
It's got to be twice, yeah. Because 3 would be too many. Okay, so 2 times 21 is 42. So 42, I'm trying to get up to 60. That means there's 18 left over. So then, it's going to be 2 and 18 over 21. Although again, I'm not going to leave my answer that way. Because that reduces. 18 over 21. What can I divide both of them by? 3. And so this ends up equaling 2 and 6/7. If you wanted to reduce this first and then turn it into a mixed number, perfectly fine. You could have done it that way as well. Because you'll notice that you could have divided both the 60 and the 21 here by 3 as well. Get the same thing. So remember from yesterday's work that this is what the graph of cosine looks like. Well, rather than just focusing on the numbers today, like starting up at 1 and then going to 0 and then to -1 and things like that, today we're going to actually look at describing it just in terms of its pattern that is following in terms of where it is at the top, the middle, or the bottom of the wave. Because by doing that, then we can start manipulating our equation and our graph in ways that don't get us mixed up with the numbers. So, the thing to note here is that cosine starts at the top of the wave. And when I say start, I mean at 0, at the x-axis, the y-axis there. It starts at 0 there. Okay? Now, As I then go to the right, it starts at the top, and then as I go to the right, the next point I hit is right here. Notice that's the middle of the wave. The next point, notice I'm going every 90 degrees. These are always every 90 degrees. The next point is at the bottom. And then we go back to the middle and then to the top. And then it repeats itself because this is a wave function. It just keeps repeating itself into infinity, doing the exact same. And so we can see that the pattern for cosine looks like this. And this is a pattern you should now know going forward. If you want to write it down as a way to remember it, that would be a good idea. That cosine starts at the top, and then from there it goes top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, top, and so on and so on and so on into infinity as many times as our particular graph and grid that we are using requires us to use it. Knowing that pattern helps when we have to go and start making a graph that looks like this, where we're all of a sudden transforming our graph. Like I'm going to take my cosine and shift it up too. You've actually done graphs kind of like this before. On WAMAP, we were able to make the graph of the wave, but the cool thing about WAMAP was that we could then just take each of these points and click and drag them up 2 units. And then the whole graph went with it. And so we can see, if I drag them all up 2 units, this is where we end up. But this could be a little bit awkward to draw, especially at the time that we start putting multiple transformations in all at once. Like we shift it and then we stretch it, that sort of a thing. And so I'm going to be showing you a little technique here that's going to help lay a foundation for being able to handle those tough ones that come up later. When we take a look at starting this kind of a problem, we can actually envision the original graph as being bounded by 3 different lines. And these 3 lines represent the top, the middle, and the bottom of our curve. I'm going to start this graph that I'm going to make here in a minute using those 3 lines. And I'm going to draw each of those in where they go. Because if I can see where each of those lines are, I know that every single point that I plot for this cosine graph is going to be on one of those lines. And we're actually going to get a nice little pattern going with it. And so this is going to be our end result. So in a couple minutes, you will have one of these on your paper, but we're going to talk through how we actually get there and what order to do this in, so that actually hopefully makes some sense along the way. So to make this graph then, I'm going to start by drawing in the 3 dotted lines. When I draw in those 3 dotted lines, the first one I make a habit of drawing in is the midline. And the reason is because the midline is normally at 0. And if this whole thing moves up or down, then I can go ahead and move that, and everything else will follow it. So if the midline is normally at 0, and I move it up 2 units, where is it now? Yeah, it's just at 2. And so I'm going to go on my graph up here, and I'm going to go to where y equals 2, and I'm going to draw a dotted line across there. You do need to make it dotted. A solid line means it's part of the graph. A dotted line means that we're just showing our work. From there, you'll notice that the distance between the midline and the maximum there, it's 1. The maximum should be up 1 above that midline. The minimum, it should be down 1 below that midline. So now that I drew in my midline, I know draw another dotted line, 1 above it, and a dotted line 1 below it. So that we're looking at something that looks like that. We draw those first. Now that we have our dotted lines on there, I know that every point that I'm about to plot in making cosine has to be on one of those 3 dotted lines. If I find myself putting a point here on the axis, I know something bad happened because I don't have a dotted line there. Everything has to be on one of those 3. Now, for cosine, we talked about this a little bit a minute ago. Where does cosine start? The top, the middle, or the bottom? It starts at the top. And so that means that I go to where I start. Of course, that by start I mean the y-axis here. And I go to the top. I put the dot on the top line. And remember, we're putting a point now every 90 degrees. So we're always going at 90-degree intervals from there. After the top, my pattern tells me to go where? Middle, absolutely. And so I put my next point in the middle. And then we go to the bottom. So I put my next point at the bottom. And then middle, and then top. I'm just following that same pattern of top, middle, top, middle, bottom, middle. That pattern goes left and right. I fill in my graph. Every single point, notice, ended up on one of those lines. And that way I make sure that I've actually shifted it up to right. I haven't lost track of any of the points along the way. I didn't have to do a bunch of calculations. Once I drew in those dotted lines, I knew where it was. I wasn't having to try to remember, oh yeah, I forgot to add 2 there, or whatever. All right, so we're going to practice that idea using this setup, where we're vertically stretching on graph by a factor of 4. All right. Normally, my midline is at 0. If I'm vertically stretching something, basically I'm pulling it away from the x-axis, pulling it upward and downward. But if I'm at 0 already, that means it can't get pulled anywhere. It's already on the axis. And so the midline then is actually going to be right at 0. So start by drawing in a dotted line on 0. And yes, I know it's a thick line, but make yours even thicker because you want to be able to see that that's the midline so that you remember it's got to be on a dotted line and you're actually plotting it on a dotted line when you do that. Now the stretch by a factor of 4, though, it does change what's going on in terms of our top and bottom. Our top is normally at 1, but it's not going to be here. Instead, I'm stretching that point to be 4 times as tall. So instead of going up 1, I need to go up 4. And so draw your maximum line up at 4. And then from there, normally we put our minimum down 1. But again, that is also being stretched by a factor of 4. And so if I multiply that distance of 1 by 4, then that means we're going to be going down 4. And so I put my next dotted line down -4. Once you've drawn in your dotted lines, making your graph from there, it's all the same as what you've always been doing. Cosine starts at the top. And so I put my first at the top. That is, I put it on that top dotted line. And then once I know that that starts at the top, I know that every 90 degrees, and always be looking when you first start a graph, how far apart are the 90 degree marks. Every 90 degrees now, I'm just following that pattern. So I just did top, so it goes top, middle, bottom, middle, top, middle, bottom, middle, top, and so on. We do that all the way on the right side. Do it on the left side. You got all your points plotted at 90 degree intervals. You go ahead and draw the curve that goes through. And then you're done.